Now effect of dielectric, dielectrics in capacitors. Now suppose these are the two plates of a capacitor A and B, and plate A having charge Q, so that plate B will have charge minus Q. Now if we are looking the electric field between the plates, this. So electric field between the plate due to the positive charge and due to the negative charge. Electric field due to positive charge in this direction, due to negative charge will also in the same direction. The net field is your field due to positive charge plus field due to negative charge, which is your Q by 2 epsilon naught plus Q by 2 epsilon naught. The net field is your Q by A epsilon naught. This is the effect of, if this is the electric field between the plates, and that direction is your from positive charge to negative charge. Now if the space between the plates of capacitor, the plates are already having charge Q. Plate's charge has not been changed. It already have charge Q and minus Q. But now let here, a dielectric slab is almost just same dimension as the dimension between the plates of. Now this is your dielectric slab. If this dielectric slab is placed between the plate and it has dielectric constant K, then what will happen here? Because of this dielectric slab, here negative charge will appear and here positive charge will appear. So that negative and positive charge will decreases the electric field, which was your E. So now what is the new electric field in that case? E net. Due to this charge, electric field was okay, Q by A epsilon naught. But due to the polarized charge, electric field direction is this, the minus charge polarized by A epsilon naught, and already we have calculated how much polarized charge, because here Q is the charge which is producing the field. So polarized charge is your Q 1 minus 1 by K. So finally we can get E net is equal to your Q by A epsilon naught K. So this is the electric field between the plates of capacitor, means electric field decreases by factor K, like this. So net field decreases by factor K. So potential difference between the plates here decreases, we can increase its capacity. So this is the actual effect of dielectric slab. So now if in this case A is the area of cross section and D is the area of the surface of plate and D is the separation between the plate. So if capacitance is your, here you see C is nothing, Q by potential difference. Potential difference here nothing, E into D. So which give us Q, E value your Q by epsilon naught A into D. So this will be your epsilon naught A by D. Now in this case, if we are looking the capacitance C in a medium, medium means dielectric medium has been kept. So that is also charge on the plate is still your Q. Charge on the plate here is still Q, but electric field between the plates will change now. It become your Q by K epsilon naught A, and gap is still your D. A is the area, is still your A, the gap is D. So it become your K epsilon naught A by D. So this value your K times C. It means due to introduction of dielectric slab, capacity of capacitor or capacity of the capacitor your increases by a factor K when slab is completely filled the gap between the two plates. So this is the main effect of dielectric slab. Now we can give much more charge till its capacity, till it does not have same field E, because it has limiting value of field is your Q by A epsilon naught. So we can give or we can increase charge by how much factor? We can increase charge by a factor K, so that its energy will also increases. So now see the different effect in the between the capacitance when dielectric slab is kept between the two plates. Now when dielectric slab partially filled the gap between the plate, partially fill the gap between the plates, then see the effect. It means in the previous case we took, if the dielectric slab completely fill the gap between the plate, but here we are taking the different case. Again here, this is the capacitor and D is the separation between the plate, A is the area of the plate. Now here we are using two different plates and their width are T1, T2 and their dielectric constant are your K1, K2 like this, in this manner. And as usual, charge on the capacitor plate your Q, here your minus Q. Now if we are looking the capacitance across the terminal M and N. Come to the basic fundamental formula of capacitance, Q by V positive minus V negative. Potential difference between the positively charged plate to the negatively charged plate. How to calculate? See here, if the slab is not there, then the electric field is your Q by A epsilon naught. That can be said as a external electric field produced by the plates on a charge. So that field will be remain in the gap. This is your E field. As we have derived, inside a slab field will decreases by a factor K. So here field will be your E by K1. Again here field is your E. Again here field your E by K2 and again here field your E. So we can say here potential difference between the plate is your this electric field. First potential difference between these two surfaces from here to here. From here to here let gap is your x1. So what is the potential difference here? E into x1. Now from here to here electric field your E by K1 and thickness your T1. So this can be written as E by K1 into T1. Similarly, next region where no plate was there. So this was the field and this let width is your x2. So we can write Ex2 similarly E by K2 into T2 plus Ex3. This is your x3. So this is the potential difference from one plate to another plate. Now E we can take common here. So x1 plus x2 plus x3. x1 plus x2 plus x3 is nothing, d minus T1 T2, like this. This is the value of x1 plus x2 plus x3, and the remaining term will be your T1 by K1, T1 by K1 plus T2 by K2. So, this is the V positive minus V negative. And what is the value of E? E is your Q by A epsilon naught. So, we can substitute this Q by A epsilon naught D minus T1 plus T2 plus T1 by K1 plus T2 by K2. This is the V minus positive negative. Now, see capacitance. Capacitance C is equal to Q by this. Q by this is the capacitance. So, new capacitance is equal to your epsilon naught A by D minus T1 plus T2 plus T1 by K1 plus T2 by K2. Likewise, that means when the space between the dielectric is your space between the plates is not completely filled by single dielectric, if multiple dielectrics are there, then we can use this relation. And moreover, if one of the platelet or any plate is your metallic plate, if one of the plate or any plate is metallic, then for metals K is equal to infinity. Then for metals K is equal to your infinity. So, suppose it is given, let for example second plate is your metal plate. Second plate means this T2 thickness, just put the value of K2 your infinity. So, here you will get a 0 value, then rest of the relation will remain as it is. So, this is the effect when dielectric slab partially fill the gap between the plates. Now, see the another different type of combinations. Now, in the second case, let a dielectric is your one of the dielectric filled the gap d by 2 and another is also your d by 2, but it having different dielectric constant K1 K2, and the question is again what is the equivalent capacitance. So, this can be replaced. See, equivalent capacitance means we are connecting a battery between M and N. So, whatever charge will go here, that will come out through this. So, here it can be taken as a 2 capacitor and both of them are in series like this. This is C1, this is your C2. C1 means it is a capacitor filled with a dielectric K1 and C2 means a capacitor filled with dielectric K2, and the gap between the plate your D1 and D1 D by 2. So, C1 is equal to your K1 epsilon naught A d by 2 and C2 is K2 epsilon naught A d by 2 like this, and these two are in parallel. So, CMN is nothing C1 C2 by C1 plus C2 like this. So, if this type of space or this type of dielectrics are filled, we can like this. Now, see another example, third one. If the gap between the plates are filled in this manner, see here M and N. Let one dielectric here K1 and another dielectric here K2. Gap here is still your D, but this area your A by 2, half of the space filled with dielectric K1, another your dielectric K2. So, if this we are looking here, So it is equivalent to one upper part of the capacitor, or upper part act as one capacitor, lower part act as another capacitor, and these two are in a parallel like this. In this manner we can see C1, C2. So what is the value of C1 here? K1 epsilon naught, area become half, A by 2, and gap still remain your D. This is your C1. And C2 your K2 epsilon naught, A by 2D. Now C Mn will be your C1 plus C2 epsilon naught A by 2D K1 plus K2 like this. In this manner we can do if these two are arranged like this. Similarly, see the another part. Let dielectrics are kept like this. This is your D by 2, this is D by 2, here area your A by 2, this area A by 2, and this is your D. Here, if this is the situation here, so now these two can act as a two capacitor in series, this is another capacitor, and this combination are in parallel like this. M and N. So C1, C2, and lower one is your, let C3, because of their respective value K1, K2 and K3. So C value here C1 is your K1 epsilon naught, area your A by 2, gap is your D by 2. So this will be your K1 epsilon naught A by D. Similarly, C2 will be also K2 epsilon naught A by D, but C3 your K3 epsilon naught, area A by 2, but gap is your D. And these two are now in series, then parallel with the Cmn if we want. So this can be said as C1 C2 by C1 plus C2 plus C3. Likewise, sometime they can ask if this is a equivalent to one capacitor of same dimension, A area, D gap, so what could be the value of K equivalent? See, first put the value this here, C1 C2 by C1 plus C2. The C1 C2 here, K1 K2 epsilon naught A by D square by C1 plus C2, K1 plus K2 epsilon naught A by D plus C3. C3 is your K3 epsilon naught A by 2D. Now when we are simplifying this, so epsilon naught A by D we can take outside, epsilon naught A by D we can take outside. So what is left here? That is your K1 K2 by K1 plus K2, and here K3 by 2. See. So this is the equivalent capacitance between M and N. Now if it is replaced by a single capacitor, the Cmn can be also written as K equivalent epsilon naught A by D. Now see, from this relation and from this relation, epsilon naught A by D can be cancelled. So if they are asking what is the equivalent dielectric constant of single slab which should fill between the two plates so that effect will be same, so then K equivalent can be said here K1 K2 by K1 plus K2 plus K3 by 2. Likewise, they can determine K equivalent also. Now see another different combination of this dielectric slabs. Now, if the dielectric slabs fill the space like this, let M an endpoint. This is your K1, but here you are not having K2 and this is your K3 in this manner. Normally what type of mistake we can do here? In hurry we can say that these two are in parallel, which are connected in series with this, but this is wrong, because gap between these two, this slab is d by 2 and here also d by 2, but electric field here your E by K3, here E by K2, so gap is same, the electric field should be same, which is not same. It means potential difference between this and this point and this point are not equal. If potential difference are not equal, then how these two can be in parallel? So rather, considering these two are in parallel, we can split this. We can split this into two parts. Upper part separate, lower part separate. The upper part act one capacitor, and then this is another capacitor. Similarly, lower part and this. These two are in series, these two series, then these two are in parallel. So rather considering three capacitor, we will consider, rather considering four capacitor, we will consider three capacitor, and those four will rearrange in this manner, like this. So here M and N point, this having your C1, this is your C2, this again C1, this is C3. C1 means half of this part. Half of this part, it means K1 epsilon naught, area your A by 2, gap is your D by 2, like this. So this is your K1 epsilon naught A by D. Similarly, if I am looking the C2, K2 epsilon naught, this also area A by 2, D by 2, this is your K2 epsilon naught A by D, and C3 is your K3 epsilon naught A by 2 and D by 2, so this is your K3 epsilon naught A by D. So now these two you can take in parallel, a series, then parallel. So C between M and N written as C1 C2 by C1 plus C2 plus C1 C3 by C1 plus C3, and substitute the value of C1, C2 and C3 from here in this manner. So this is the another combination or arrangement of dielectric between the plates of capacitor. C1 another arrangement. Now in this case, rather filling the gap between the plates in a straight way, if we fill the dielectric like this diagonally, then what is the effect and how we will get the answer? See, let this place filled with dielectric constant K1, and this is your filled with dielectric constant your K2, and assuming a square plate of edge L. Suppose we are assuming the plates are square and the edge length means L, like this. Then how to calculate? So how to calculate equivalent capacitance between M and N points? So our aim is the calculation of equivalent capacitance between M and N. Here thickness of dielectric slab from one end of the plate to another end is continuously vary. If that thickness here continuously vary, then how to solve such problems here? See the effect of this. What can be done here? Let in this plate, the plate can be divided number of small thicknesses. So this is your total plate, like this. This is your total plate. I can divide, the plate has been made with a number of this small strips. So if I am considering x distance from here and I am taking dx strip. In this dx strip means like this. In this dx strip, from here to here one dielectric field, from here to here another dielectric field. So we can have, it is just like a two capacitor, one from here to here, another from here to here, and these two are in parallel. Sorry, these two are in series. See, this is one capacitor, this is another capacitor, and these are in series. And in this capacitor, dielectric your K1, and in this capacitor your dielectric your K2. And if Y is the gap between these two plates, see, this is your one strip, another strip, one plate, another plate, gap between these two plates, your Y here. That gap will be your D minus Y, like this. Similarly, if we are considering here another capacitor, like that, so whole thing can be said as from one end to another end, number of different capacitor, two capacitors, C1, C2. Here you may have let C3, C4. Similarly, you may have here your C5 and C6. All are connected in parallel like this. So what we will do, we will calculate for C1, C2 value, then we can simply add, just like in addition in case of parallel. So first C1, C2, let this value is C1. The C1 is your K1 epsilon naught area of the plate. This thickness is your dx, but since the plate is a square plate, so it will go up to the L. So K1 epsilon naught L into dx is the area, and gap between the two plates over here D minus Y, and C2 will be your K2 epsilon naught L dx by Y. This is the C1, C2, and these two are in parallel, and this is the part. So that we can say DC equivalent, or C equivalent means DC equivalent, and this is your integration of C1 C2 by C1 plus C2, because these two are in series. Now C1 C2 by C1 plus C2. So K1 epsilon naught L by D minus Y into K2 epsilon naught L by Y and dx whole square by C1 plus C2 epsilon naught L into dx, we can take common K1 by D minus Y plus K2 by Y. And now check it. Epsilon naught L dx, epsilon naught L dx we can cancel. So what is left here? K1 K2 epsilon naught L dx by here K1 Y plus dk2 minus k2 y. So dk2 plus y we can take common, k1 minus k2 like this, in this manner. Now this is your dx and here your y. So we have to convert y in terms of x. So see in this, if we are considering whole this triangle, so this is your d and this length is your L. If this angle is your theta, so see in the diagram, tan theta is your d by L, and this further written as y by x. So y by x, so y can be written as d by L into x. Substitute the value of y here. So C equivalent will be your k1 k2 epsilon naught L dx by k2 into d plus y. Y is your d by L into x. D by L k1 minus k2 into x. Now we can integrate, and limit of integration will be your from x equals 0 to L. 0 to L. Now simplify this one. K1 K2 epsilon naught L ln. Ln will come here. D by L k1 minus k2 x plus k2d by d by L k1 minus k2, and limit of integration 0 to L. See. Now simplify. So after simplifying, we will get k1 k2 epsilon naught L square by d k1 minus k2, and ln here when L is there. So this L and L cancel. So dk2 and dk2 cancel. So what is left? dk1 and x is here dk2. So ln k1 by k2. This is the C equivalent if the dielectric slab is kept diagonally between the two plates of a capacitor. So in this manner we can able to solve problem if the dielectric slab is not completely straight, or in the different way it has been occupied the space between the plates of a capacitor.